Hi guys, just give me a few minutes. We'll start. I hope you can see the screen, right?
Sir.
Okay. So did you try solving problems from limits? Anyone? No? Okay. Anyway, I'll complete the. Just give me 5 minutes. We'll start. Okay, let's start. Hopefully you have the idea of what limit is, right? See, in previous class we had discussion on over it, what limit is. That means it is approaching the value. Okay, it is not exactly the value, but it is approaching it from the left and the right hand side. And we have also seen that if the left hand side and the right hand side limits are equal, that means the function is continuous, right? We have seen that. We have also seen that some of the indeterminate forms, and how we are going to solve the indeterminate forms, we are going to see that in upcoming lectures. So today mostly we'll be focusing on some basic limits and its property. Okay, then we'll have derivatives, and after that, after understanding differentiation, hopefully you guys have already studied differentiation in physics. Okay, but we'll have a very deep idea about what exactly differentiation is. Okay, so with all that, let's try to solve this problem. So our first problem will be, see, the given function is f of x is equal to x minus 2 for x lesser than 0, 0 for x is equal to 0, and x plus 2 if x is greater than 0. Now you need to find out what is limit x tends to x tends to 0 f of x. You need to find this limit. Can you try, give it a shot? Hari, can you solve it? Hari, Mitran, who else? Ashwin is also there. Who is there? Okay, Shreya, you have also joined. All right. Sham. All right, just try to solve this limit. Shreya, were you there in previous class when we discussed about limits?
Yes, sir.
Okay. Can you try and solve this limit?
Yes, I will try.
Yeah, just try it. You can make it a tabular form. It's up to you. Okay. Just remember, limit means the function is approaching from left side as well as right side. Here the given value is 0. So it is coming to 0 from left and from right side. Okay. All right, let's try to solve it. See, first try to understand this problem. Okay, so for that we'll be plotting the curve of the given function. Let's try to understand it. Okay, y x. Now we have to plot f of x. Okay, so it's given that x lesser than 0, the value of function is x minus 2. That means if you substitute 2, the value of function will be 0. Sorry, not 0. That means x less than 2, right? That means all the values to the left of 0. This point here, it is 0, right? Now, this function is valid x minus 2 when x is less than 0. That means all this side. X plus 2, all this side. And 0 at x is equal to 0. That means first thing is, first we are plotting the middle value. This one is the value of y is 0 if f of x is, if x is equal to 0. Now, if x is equal to, let's say, minus 1, okay? So if x is equal to minus 1, the value of y will be minus 3, okay? If x is equal to minus 2, the value of y will be minus 4, okay? So we see that if you join these two lines, it will come around here, but the value of x is not equal to 0, okay? So that means at x is equal to 0, the value is 0. Similarly, here, let's plot this one, this function, x plus 2. So if x is greater than 0, so when it is greater than 0, after here, right, from the origin to right side of the origin, it is greater than, x value is greater than 0, not at origin, okay? So if you put x is equal to 1, what you'll get? You'll get 3. So if x is equal to 1, you'll get the value 3. If x is equal to 2, you'll get 4. Somewhat around here, like that. All right. So let's join these lines. Something like that. But it's not at x is equal to 0. See? Here also there is no equality sign. Here also there is no equality sign. When x is equal to 0, the value of y is 0. So that is this point. All right. Got it? See, I'm darkening the circle. That means it represents the value, it exists at that point at x is equal to 0. Here it is a hollow circle. If you see, this is hollow circle. This is also a hollow circle. That represent it is not valid at that point. Okay. Now, so this was graph. And from graph, what we can say? We can say, okay, this was the graph of the function. Now let's make the table of this function, of this problem. Okay. So let's try to make the function table. So for the value of x, what will be the value of f of x? Okay. So suppose if x is equal to minus 0.1, what will be the value of f of x? For x is equal to minus 0.1, what is the value of f of x? Use your calculator. We are understanding what limit is. How much?
Minus 2.1.
Minus 2.1, right? Okay. Now, okay, so that means try to understand minus 0.1. It is where somewhat around here, right? So for that, you have got the value of this f of x, the function. That means this point. Okay, now let's come a little bit closer to it. Okay, so minus 0.0001. Okay, what will be the value of y?
2.0001.
2 point minus
Minus
actually
2 point, minus 2.00.
0001, right? Around like this, right? Okay.
Yes.
Now if x is equal to, let's say, 0.0001, what now this, let's go into the positive side, this side, right hand side. Here we are going. That means, see, we have to find the limit at this point. So we have to approach in this manner. That means x is coming from this side and from this side. Okay, 2.0. This is the given point. Okay, now tell me what's the value? So it is 2.0001, right? Something like that, isn't it? but it will never come to 0. This value will not come to 0, will it? Because at x is equal to 0, the function is what? 0. So you will see left hand limit x tends to 0 minus f of x. Okay, this is your left hand limit. What is the meaning? Meaning is somewhere see, x is equal to 0 is this point. So 0 minus is around here, somewhere this point. Okay, if you zoom it, so 0 minus is somewhere, let's say here. Okay, and 0 plus is somewhere here. That means the function is approaching from this side and this side. This is the, see, this is the left hand limit and this is the right hand limit. Understood? So here we write 0 minus, this side we write 0 plus. Okay, so that's the meaning. So 0 minus f of x. So this will be equal to limit. So how you will write this? X tends to 0. Now what is the value of function? X tends to 0 minus, 0 minus, what is the value of function? X minus 2, right? Isn't it?
Yes, sir.
Yeah. Now right hand limit, what you will write? Right hand limit. So limit x tends to 0 plus f of x. This is your right hand limit, which is limit x tends to 0 plus x plus 2, right? Isn't it? This is not equal to, this is not equal to 0. This is also not equal to 0. Of course not, it is equal to 0, right? And but limit x, not limit. If you find the value of function, so f of 0 is how much? What is the value of function at x is equal to 0? So you can write like this, f of x is equal to 0. What is the value of function? If x is equal to 0, what is the value of function?
0, sir.
0, right? Now you see left hand limit and right hand limit are not equal, of course. And that is also not equal to the value of function at that point. That means the limit at this point at x is equal to 0 does not exist. Okay, see, whatever the value you will get, you will not get 0, right? You will never get to 0, will you? If you put x is equal to 0 minus, let's say 0 minus is which value? Let's say this value or closer this value, isn't it? So around you will get something 2. So if you find it around, you will get 2, isn't it? Here also around you will get 2, isn't it? Yes or no?
Sir.
This value will be approximate. Left hand limit is approximately 2, minus 2, I'm sorry. And right hand limit is approximately 2. But the value of function at that point is 0, right? So left hand limit is not equal to right hand limit, or this is also not equal to the limit at that point. Okay, so you will write the limit does not exist. The limit of f of x at x is equal to 0 does not exist. Understood? So at x is equal to 0, this limit does not exist. See, only if you find for x minus 2, limit will exist separately for this, but not with the combined function. Understood? Okay, let's try to solve another problem. A little bit of, so have I given you some, theorems of limits? Okay, let's write down before we solve some problems. Okay, number 1, if suppose limit you are given the difference or the sum of two function at x is equal to a. So f of x plus or minus g of x, you have to find this. So you can separate these two. Limit x tends to a, f of x plus or minus limit x tends to a, g of x. Okay, so first, second, that means you just separated this two. Now, if suppose limit x tends to a, product of these two functions are given, g of x, Okay, then you can write limit x tends to a f of x multiplied by limit x tends to a g of x. But there is a condition here. Okay, you cannot just write for all functions. Okay, the condition is, first thing is f of x and g of x should be defined in the same domain. Okay, so domain of f of x and g of x, domain and range, sorry, of these two functions must be same. Must be defined, you have to write, sorry. Same is not the correct statement. All right. See, in your book, you don't have to worry about this. Okay, but I think you should be knowing these information. Same thing goes with limit. If you have x tends to a on g of x, so you can separately, you can find limit x tends to a f of x upon limit x tends to a g of x, provided this condition as well as g of x should not be equal to 0. Okay, g of x cannot be equal to 0. All right, so with this information, shall we solve? Okay, one more thing, fourth one. If you have like limit x tends to a and you are multiplying it some function with a constant g of x, so how you can write? You can write this as, you can take k outside and you can just find the limit of the given function, because anyway k is the constant, so it doesn't matter. Okay, all right, let's try to solve some of the problems, because theorems will not end. And okay, so find the limit x tends to 1 x cube plus x into x minus 1. Find out how much was the value. Yeah, what was the value? How much you are getting?
Sir,
You just substitute the value of 1 here. It is not indeterminate form, so directly you can
1, sir.
Okay, so this is 1 cube plus 1 into 1 minus 1, so that will be equal to 1. Okay, directly you can substitute, no issues. All right, see, this is limits of polynomials that we are studying, and any polynomial function f of x, okay, it's not a problem. Any polynomial function f of x can be written as like a naught plus a1x plus a2x square plus a3x cube, like that, right? Isn't it? Polynomial functions can be written like that. So similarly, there are some functions which you can write like this. Any functions you can be written in form of polynomial functions, like for example sine x. Okay, sine x, that means here f of x is equal to sine x. Using Taylor series, you can write x minus x cube upon 3 factorial plus x to the power of 5 upon 5 factorial plus, minus x to the power 7 upon 7 factorial, and so on. Okay, up to infinity. All right, and cos x can be written as 1 minus x square upon 2 factorial plus x to the power 4 upon 4 factorial minus x 6. See, cos is even power and sine is odd power, 6 factorial up to infinity. All right, so these two you will learn, these two, not here. These two we find using Taylor series or Maclaurin series, actually. Taylor's expansion. Okay, now see, it is very easy to find the value of sine limit. Like, you will see that limit x tends to 0, sine x is equal to what? You will see that the value is 0. The value is 0. And you will also see a theorem that limit x tends to 0, sine x upon x is equal to 1. Why? Okay, see, always remember these angles. Whenever you are writing these angles, these angles are always in radians. Okay, see, in general mathematics, we always use radian as measurement of angles. Do not use degrees. All right, understood?
Yes, sir.
Yeah. So that's why mostly you will see problems like limit x tends to pi by 6. You will not say 30 degree. It will not be written like that. Okay, if it is written, then it will have to be defined. We'll see these proofs, but before that we'll see some of the problems based on algebraic formulas that we have just seen. Okay, so find out limit x tends to, let's say, 0, x square, sorry, limit x tends to infinity, 1 upon x. Yeah, what will be the value? Tell me. What is 1 upon infinity? You just substitute, no? 1 upon infinity. What is that? 0. Okay. If you don't know, just note it down. Any finite value upon infinity is equal to 0, other than 0. Okay. 0 upon infinity is not 0. 0 upon infinity is indeterminate form. So except 0, if you have any finite value, so this will be equal to 0. Now use this concept. Okay, use this and solve this problem. Limit x tends to infinity, x square minus x cube upon x to the power of 4. Tell me the value. Yes, who will solve it? You can solve it. It's the same concept.
Defined, sir.
Huh? What? Yes, tell me.
Wait, sir. Wait. Yes, Shreya.
Seven.
You just first solve the function, okay? So you can write limit x tends to infinity. What you can write? X square upon x to the power of 4 minus x cube upon x to the power of 4. Now you can write limit x tends to infinity. See, these are two separate functions, f of x, g of x. If you want, you can separate it. If you don't want, you can just solve it like that. So this can be written as 1 upon x square minus 1 upon x, right? So if you substitute it, what you'll get? 1 upon infinity minus 1 upon infinity, which is equal to 0 minus 0, which is equal to 0. Just give me a moment. Hello? Okay, so we'll try to solve another problem. All right. Okay, so just try and solve this one. Limit x tends to infinity. What problem was that? Okay. Limit x tends to 0. X, okay. Just give me a minute. Sorry. Solve it. Wait. Solve this limit. Yeah, how much you are getting? You just need to multiply these functions in the numerator. Okay, that's it. So limit x tends to infinity. Multiply these functions. What you'll get? So 3x cube minus x square multiplied by x square minus 1 upon x to the power of 5, which also you can write limit x tends to infinity. Now you just multiply these functions. What you'll get? 3x to the power of 5, right? Minus 3x cube minus x to the power of 4 minus x square divided by x to the power of 5. Now separate these functions. Limit x tends to infinity. 3x to the power of 5 upon x to the power of 5 minus 3x cube upon x to the power of 5 minus x to the power of 4 upon x to the power of 5 minus x to the x power x square upon x to the power 5. All right. Now just substitute the limit. See, this will be equal to 1. So again, you can write limit x tends to infinity. So 3 minus 3 upon x square minus x to the power, x 1 upon x minus 1 upon x cube. So this will be, see, if you substitute the limit, these values will be 0, right? These value will become 0 if you substitute the limit, but 3 you cannot substitute. So this answer will be 3. Understood? Or do you need more explanation on this part? You just need to
Understood.
got it? Okay, let's try to come back and solve. Okay, try to solve this problem. Okay, limit x tends to 2, x cube minus 2x square upon x square minus 5x plus 6. Solve it. See, if you directly substitute the values, see, if you substitute x cube means 2 here, what you'll get? 2 cube minus 2 into 2 square upon 2 square minus 5 into 2 plus 6, right? So in the numerator, you are getting 0, right? And in the denominator also, you are getting 0. 4 plus 6, 10 minus 10. 4 plus 6, 10 minus 10. So 0. 0 by 0. Now this is indeterminate form, right? Isn't it? Yes or no?
Yes.
Yes, sir.
Yeah. Now this is indeterminate. How do we solve indeterminate form? Now what you have to do, these type of limits, see, there is one rule, L'Hopital's rule, which we are going to study a little bit later after studying differentiation. First, just try to understand some of the limits of this order can be solved by just arranging, by just manipulating this algebraic equations. Okay, so how we can do it? You'll write limit x tends to 2. Now, how can we write? Just take 2x common. Sorry, what we can take? X square can we take common? X, isn't it? X square can we take common? Yeah. So what will be there? X minus 2 upon from the numerator we have taken x square common. In the denominator, what we can do? This x square, we can just find the factors of this. X square minus 5x plus 6. What will be the factor of this? Find out what will be the factor of this expression. Can we write this as x square minus 3x minus 2x, right, plus 6, isn't it? Can we write like this?
Yes, sir.
Yeah. So what we can do, x we can take common. This will become x minus 3, right? From here what we'll get? Minus 2 if we take common, we'll get x minus 3. So x minus 2, x minus 3. Can we write like this? So x minus 2, x minus 3. X minus 2, x minus 2 we can cancel. So what will have limit x tends to 2, x square upon x minus 3. Now if you put x is equal to 2, what you'll get? 2 square upon 2 minus 3. Now this is not indeterminate form. What is this? 4 upon minus 1, that is equal to minus 4. Got it? So you just need to solve the algebraic equations. You have to make the equation such that it is not indeterminate form. Right now this is indeterminate form. In its raw form, it is 0 by 0, which is indeterminate form. You have to convert this equation, convert this algebraic equation in such a form which is not indeterminate. All right, let's solve another problem. This one you will solve by yourself. Okay. So, okay, find out limit x tends to 2, x square minus 4 upon x cube minus 4x square plus 4x. Solve it yourself. See, this is really easy. The same method. See, write down the numerator and the denominator in its simplest form. Okay, or in its form of factors. What will be the factor of numerator? What will be the factor of denominator?
So 0, sir.
0 you are getting?
Yes, sir.
How come you are getting 0? What you are doing? See here, what we can write, limit x tends to 0, x square minus 4. So can we write this as x plus 2x minus 2 in the numerator? See, isn't it? See, x square minus 4 is equal to, if you substitute 0, what you'll get? X square is equal to 4, x will be equal to plus or minus 2, right? That's what I've written, no? And this is a square minus b square. And in the denominator, see, x is common in all. So x is one of the factor. Sorry, x is equal to 0. Yeah, x is equal to 0 is one of the factor. So you can write x square minus 4x plus 4. Yeah, is it correct? Yes or no?
Sir, yes, sir.
Okay, now can we write this as limit x tends to 0, x plus 2, x minus 2, we are getting x. Can we can tell me the factor of this? Factorize this one. See, this is a minus b whole square, x minus 2 whole square. See, if you, let's find out the factor. Let's not write directly. If you use the formula b square minus 4ac upon 2a, minus b plus or minus square root of b square minus 4ac upon 2a, right? So minus b is how much? Huh? Minus 4, right? So this will be plus 4 plus or minus square root of b square, 16 minus 4 into 1 into 4 into 16. That means this will be 0. So 2 times of 1. This is 0. So 4 upon 2, which is equal to 2. So both values are 2. Both the factors are 2. Got it? That means x is equal to 2 and x is equal to 2 values of x, both are 2. So this can be written as x minus 2 whole square. Understood? Yes or no? Or we can also write this as x minus 2 into x minus 2. So 1x minus 2 you can eliminate, right? Now, even if you if you substitute x is equal to 0, what you are getting? Now you have got limit x tends to 0, x plus 2 into x minus 2. If you substitute the value of 0, what you are getting? What you'll get? X is equal to 2, no? Sorry, why we are writing x is equal to 0? X is equal to 2, sorry. Now substitute, so this here you will get 4 upon 2 into 0. That means it is still undeterminate form. Okay, so the limit is not defined. Still we are getting infinity, so limit is not defined. Limit, even after solving we are not getting, so limit is not defined at x is equal to 2. Okay. See, if you want to check these, whether it is defined or not defined, you can always plot a graph. Okay, always you can go to Desmos and try and plot the curve. You will find out why it is not defined. Okay. Do you want me to do that? Okay, all right. Okay. So what we have got in the numerator, we had x plus 2, x plus 2, right? X plus 2. And okay, let's put it in bracket. All right, divided by, sorry, divided by x multiplied by bracket x minus, what is that?
2, sir.
X minus 2. Okay. Okay. Now at x is equal to 2, we need to check, right? See, at x is equal to 2, at this point, the function is not defined because the value is approaching infinity. Similarly, if you try to find the value of function at x is equal to 0 also, it will not be defined. See, it is not defined, isn't it? Can you see that? So at x is equal to 0 and at x is equal to 2, the value of this function is not defined because you can see it from here itself. If we solve these one, x plus 2 upon x into x minus 2. See, denominator, the function, the condition is denominator. The function is only defined if denominator is not equal to 0. So x into x minus 2 should not be equal to 0. That means x should not be equal to 0 or x should not be equal to 2. Understood? That's why even if you find limit x tends to 0, you will again get the same thing you will get. Okay, it is not defined. So limit x tends to 0 of function f of x is equal to limit x tends to 2 of the function x, which is not defined. Okay. Let's try to solve problems from the exercise. We have other theorems, Sandwich theorem and this theorem and that theorem. Before that, first solve some of the problems. Okay. So exercise 13.1. Okay. Solve question number 2. Limit x tends to pi x minus 22 by 7. Yes, tell me. Anyone, please tell me the answer. Someone, please.
0, sir.
Why 0? You have to explain it.
Because pi is equal to 22 by 7, sir.
Okay, if
Then,
pi is not equal to 22 by 7, then
then x minus 22 by 7, sir. Anything the values in limit
no, it
extends
will
to
be,
anything.
see, it is actually pi minus 22 by 7, right? The
Yes,
value is
sir.
actually this. If you assume that pi is equal to 22 by 7, then it is equal to 0. Okay?
Okay, sir.
Okay. All right. So solve question number, let's say 5. Limit x tends to minus 1, x to the power of 10 plus x to the power of 5 plus 1 upon x minus 1. See, this function is not defined at x is equal to 1 because the denominator should not be equal to 0. That means x cannot be equal to 1. Okay, other than that, the function is defined. Now find out.
Minus 1 by 2, sir.
What?
Minus 1 by
Minus 1 by 2? I don't know.
Sir,
Okay,
minus
so
1 by
if you
2.
substitute the limit, you'll get minus 1 to the power of 10 plus minus 1 to the power of 5 plus 1 upon minus 1 minus 1. So how much you are getting? So this is 1 minus 1 plus, plus 1 upon minus 2. So this will be minus 1 upon 2. Okay. Okay, solve problem number 10. Limit z tends to 1. Z 1 upon 3 index minus 1 z 1 upon 6 minus 1. Yeah. Yes, anyone tell me the value. First tell me what form is that? If you substitute z is equal to 1 here, what you will get? Huh? See, if you substitute z is equal to 1, 1 to the power of 3 minus 1 upon 1 to the power of 1 by 6 minus 1. So that is equal to 0 upon 0 form, right? Which is indeterminate, isn't it? Yes
sir.
or no? So how you will solve it? What you will do? You have to solve this, no? Okay, so here we are going to learn a new theorem, which is limit. I'll write it here itself. Limit x tends to a, x to the power of n minus a to the power of n upon x minus a. This is equal to n a to the power of n minus 1. Write down this. This is your theorem number 2. Use this formula and find out the limit. So what you will do, you will substitute it here. Now, if you substitute, let's say z to the power of 1 upon 6, let's substitute. Let this to is x. Let this be x. Okay. So if z is tending to 1, that means x is tending to 1, right? See, if z is tending to 1, then x is also tending to 1. From here, can we write like this or not? So what we can do, we can write limit x tends to 1, x square minus 1 upon x minus 1, right? So using the formula that I just gave you, that will be equal to 2 into 1 to the power of 2 minus 1, because a is what? A is equal to 1 and n is equal to 2. Fine. So this you will get, which is equal to 2. Understood? Use this formula. This part you understood or not? See, x to the power of, see, z to the power of 1 upon 6. See, z is the power, n is in fractional form. Okay, I just converted it to rational form. Sorry, what is that? Integer form, sorry. This is fractional form, no? I converted this to, I inserted a new function, x. Okay, so if z to the if you substitute z to the power of 1 upon 6 is equal to x, that means z to the power of 1 upon 3, what you can write is equal to z to the power of 1 upon 6 square, right? Which is equal to x square. Okay, that's what I have substituted here. Okay, so here it was z tending to 1. If z here is tending to 1, that means x is also tending to 1, right? Because x is, see, if you substitute z is equal to 1, what you will get x? X is equal to what? Z to the power of 1 upon 6. If x is equal to 1, what is the value of z? Z should also be equal to 1, right? Got it? Understood or not? Any doubt here? Why we are substituting or why we are doing like that? Any doubt?
No.
Yes or no?
No doubt, sir. Understood, sir.
Okay, if you say so. All right. Now let's understand a little bit about trigonometric limits. Okay, limits in trigonometric functions. Okay, we are not going to see the sandwich theorem and all, whatever it is given. We'll have it a little bit later. Okay, so this is theorem number 5 of your book. Theorem 5. Okay, it's given limit x tends to 0, sine x upon x is equal to 1. Okay, first, and the second one is given as limit x tends to 0, 1 minus cos x, 1 minus cos x upon x is equal to 0. Okay, so these two are the theorems. I don't know about the proof in the book, but I'll tell you the simplest proof that I can tell you. limit, you can write limit x tends to 0. Now sine x, you can write this as 1 upon x. Sine x can be written as x minus x cube upon 3 factorial plus so on. Okay. Now, if you multiply these two functions, so limit x tends to 0, this first one, if you multiply this and this, it will become 1, okay, minus x square upon 3 factorial plus x to the power of 4 upon 5 factorial and so on. Now, if you substitute x is equal to 0, so these terms will become 0, right? These terms will become 0. Okay, and you will only get 1. So if you substitute the limit, you'll get 1. And that's why this value is equal to 1. Similarly, you can do it for cos x. Okay, but let's see the proof that is given in your book. Okay. Whew. Okay, sin x upon x is not given in the book. It's it's more of a theoretical concept that is given in the book, not what you can literally see in here. But let's try to prove this cos x. Now, since we have proved that limit x tends to 0, sin x upon x is equal to 1, let's try to prove cos x is equal to, see, what will be the value of limit x tends to 0 cos x? What will be the value? Huh? Cos 0? Cos 0 is what? How much is cos 0? How much is
1.
cos 0?
Sir, 1.
Yeah, just turn on your mic and say it, yeah. Don't do that. Okay, so cos 0 is 1. That is clear, right? All right. See, expansion, what we can do, you can use Taylor series to expand these also. So limit x tends to 0, 1 minus, now cos x is 1 minus x square upon 2 factorial minus plus x cube upon 3 factorial, sorry, not cube, x to the power of 4 upon 4 factorial and so on. Okay, so this is cos and upon x. All right, so limit x tends to 0. So 1 minus 1, it will be, these two will cancel out each other. These two will cancel. If you open the bracket, the sign will change, right? And this will cancel out. So it will be 1 minus 1 plus x square upon 2 factorial minus x to the power 4 upon 4 factorial and so on. Whole divided by x. All right. So these two will cancel out. Now you substitute now x. Okay. What we can do, we can write limit x tends to 0. X square upon 2 factorial will become x upon 2 factorial minus x cube upon 4 factorial plus x 5 upon 6 factorial and so on. Okay, like that. So if you substitute x is equal to 0, all terms will be 0. This is 0, this is 0, this is 0. All will be 0, right? That's why the value is 0. Because only higher power of x you will get. There is no constant term. So this is equal to 0. Understood the proof? Or if you, let's try to prove it according to your book. Okay, so limit x tends to 0, 1 minus cos x upon x. Now we'll use a little bit trigonometry here. Okay, so limit x tends to 0. Now 1 upon cos x, what we can write? 2 cos square x upon 2, right? Half angle formula, remember, upon x. So this we can write as limit x tends to 0, sine x upon 2, okay, whole divided by x upon 2. How we have written this thing? How is that possible? Sorry, this is sine, no? Why we are writing cos? Sine square x upon 2 upon x. So how is that possible? Into sine x by 2. Sorry. Is equal to limit x tends to 0. Now we'll separate these two, sine x upon 2 into sine x upon 2, okay, whole divided by x by 2. Can we write like this? Let's put, let x by 2 is equal to y. If x by 2 is equal to y, so if x is equal to 0, that means y is also equal to 0, right? So we can write limit y tends to 0, sine y upon y into sine y, right? Now we know limit y tends to 0, we can write sine y upon y into limit y tends to 0, sine y. Now this we know is equal to 1, right? We have proved this is equal to 1 and this we know is 0. Because sine 0 is 0, that's why it is equal to 0. Okay, so 1 minus cos x upon x, if x is equal to 0, the value will be 0. Okay, if you want, we can check that in Desmos. Okay, so this will be sine x. Okay, sine x. Just put that in bracket. Sine x. Sorry, my mistake. Sine x. Close the bracket. Okay, sorry. To close the bracket. Okay, divided by x, right? See, sine x upon x, how you can plot it. So sine x upon x at x is equal to 0, what is the value? 1. Can you see this? So this is how sine x upon x will look like. So in physics, you will be studying in vibration, in mechanical vibration, in waves, you'll be studying a damped wave. So sine x upon x is a damped wave, example of damped wave. Okay, you will study about that in physics. Now, if you want, you can also write 1 minus cos x, right? So bracket 1 minus cos x, all right, bracket close, divided by x. See, now 1 minus cos x upon x at x is equal to 0, the value is 0. Can you see this? Okay, so that's how you can plot these functions. All right, so let's come back here. Now with this concept, let's try to evaluate some of the limits. Okay, so limit x tends to 0, tan x upon x. Find out. Find out. Please do it fast. How you'll solve it? How you can write tan in form of sine and cos? Write down like that. Limit x tends to 0. Tan what you can write? Sine x upon cos x. Yes or no? So sine x upon cos x into 1 upon x. Now this you can write as limit x tends to 0, sine x upon x into cos x. Now you will separate these limits because the domain is same. Sine x upon x multiplied by limit x tends to 0, cos x, right? Now if you substitute, we know the value of this limit is 1 multiplied by cos 0. What's the value of cos 0? What is the value of cos 0?
1, sir.
1. So 1 into 1 will be equal to 1. That means tan x limit x tends to 0, tan x upon x will be equal to 1. All right. I know you have chemistry class. Let's do one more problem. Okay. Or shall I give it for homework? Oh, okay. Okay. Please try to solve this exercise. This is very easy now. So solve exercise 13.1. I hope you'll be able to solve all the problems. If not, please, we can discuss the concept if there is any problem in it. If you have any doubt, please let me know. Okay, limit. But the basic funda of limit is just approaching value. It is not that value, but approaching that value. Okay. In tomorrow's class, we'll try to have the idea of derivatives and continuity. Okay. And we'll learn some of the differentiations. Okay. Thank you.